So sorry for the delay. There will be a network problem, network congestion of this one. So I'm so sorry for the delay. So let's start the session again. So we have talked about the sparse indices and the dex index. That is how to use the sparse index and how to use the dense index. That is what is the difference between the sparse index and the dense index. And this is the theory that is given. This is the explanation that is given for the sparse index and the we can say the dense index, and there is a department name that is available. So it is used to locate a record if you have a dense index rather than the sparse index. However, sparse index has some advantages. So which indices will be better? That is, the sparse indices will be better as more advantageous over the dense indices, in which or in that they require less space and they impose less maintenance overhead for the insertion and the deletion. That is, they require the less space and there will be a more concept, there will be more maintenance, there will be a less maintenance, and there will be a less maintenance overhead for the insertion and the deletion. That is, if I want to insert anything, that will be deleted or that will be inserted and the deleted very carefully and very efficiently. That is, the insertion and the deletion is very or it's done very efficiently. That is, use the insertion and the deletion is very easy. And there is a trade-off that is also used for the design purpose, that is used in the processing a database request, that is used to take a time from the memory. And this is the blue axis that is available. So there is a index that is available. This is the name, this is the department name, this is the salary of the employee, that is a 65,000. And this is a sparse index, and this is a dex index with the search key department name. This is a department name, that is a search key that is available. That is a biology, computer science, electric engineering, finance, history, music, physics. For the preceding techniques to be fully general, we must consider the case where records for one such key value that occupies several blocks. It is easy to modify our scheme to handle the situation. That is, to handle the situation, it is better to modify the schemes. Then the next one is multi-level indices. That is how to use the multi-level indices. So suppose we build a dense index on a relation that is 1 lakh tuples. Index entries are smaller than the data records. So let us assume that 100 index entries fit on a 4 kilobyte track. So this is one example, that is 100 index is available on the 4 index block. And therefore the index that is used, or therefore the index that is occupied or over the 10,000 blocks, that is the 10,000 blocks are available for the data access. And such a large indexes are available in or stored on a sequential access or the disk. Binary search can also be used on the index files to locate the entry, but the search still remains the same, or the search becomes the same. That requires a large code that is used for accessing the file, that is used for the accessing the database. So this is saying the binary search can be used on the index file to locate an entry, but the search still have a large cost, and the large cost is also used for the block indices. This is the example. This is the index block 0, data block 0, index block 1, data block 1. That is used to solve the problem. And to deal with this problem, we trust the index just as we would treat any other sequential file. And construct a sparse outer index on original index, which we know, or which we now call the inner index. So there is an inner index that is also used for maintaining the sparse indices. And to locate a record, we first use the binary search on the outer index to find the record from the largest search key value less than or equals to the one that we desire. To find out the largest search key value, we find the value that is available for the large key values. Another example, an index with a 10,000 blocks that is used with the 10,000 blocks that is used with the indexes, that is used with the various concept, that is used with the various we can say the value that is available with the data concepts. So to deal with the various index files that is used for the search index that is used, that contains the various blocks, that contains the various 10,000 or the 10,100 blocks. Then next is the index update, that is how to update the indexes, or what is the value, or what is the main concern, what is the criteria for updating the value, that is the index update. So regardless of what form of index is used, every index must be updated whenever a record is either inserted into or deleted from the file. That is, either the result is inserted or either it is deleted from the file, it is carrying out or it is taking out the deletion from the file. Further, in case a record in a file is updated, any index value with the search key that is available, that contains or that is affected by the update, that must also be updated. For example, if the department of an instructor changes or changed an index on the department name attribute of the instructor, that must be updated correspondingly. That is, if any index, if any file contains value that can be changed, that will be updated automatically with the index values. Then as a result, we only consider the insertion and the deletion on the index and do not need to consider the updates explicitly. So as a result of this one, we need only the, or we need to consider only the insertion and the deletion on an index and do not need to consider the updates explicitly. We first describe the algorithm for updating the single level indices. Now, what are the various algorithms for updating the single level indices? First is the insertion. That is, the first is that the system performs a lookup using the search key value that appears in the record to be inserted. That is, which record to be inserted, it depends on the search key values. The actions the system takes next depends on the what the value is, index or the dense or sparse. That is, which index is used or the which index that will be used to take the value, that will depends on the action that will be taken to either we can use the dense index or either we can use the sparse index. Now, first is the dense indices. So if the search key value does not appear in the index, the system inserts an index entry with the search key value in the index at the appropriate position. That is, the search key value that is appeared in the index, the system inserts an index entry. That is, inserting the index entry with the search key value that is available with the various or with the appropriate position. Otherwise, the following actions are taken. If the index entry stores the pointer to all the records with the same index values, the system adds a pointer to the next record or the new record in the index entry. Then on the basis of the sparse index, we assume that the index stores an entry for each block that is available with the inserted block. Then there is a deletion. To delete a record, the system first look up the record to be deleted. Now, how to delete the record? It also depends on the whether which index is used, whether we are using the dense index, whether we are using the sparse index. So in the DEX indices, if the deleted record that is available, that contains various file, that contains various record that is available. So in case of dense indices, if we deleted the record was the only record that is to be deleted, then with its particular search key value, then the system deletes the corresponding delete key, or the system deletes the corresponding index entry from the index. That is the specified index entry will be specified, or the specified index value will be deleted from that search key. Otherwise, if the particular search key is not available, otherwise the following actions or the following search criteria will be followed. That is, what are the various criteria that is followed with this one? That is, if the index entry stores pointer that is used or to all the records with the same search key value, the system deletes the pointer to be deleted or to the deleted record from that index entry. This is one of the criteria, that is, if the index value or if the index entry stores pointers to all the records with the search key values, then the pointer that must be deleted or recorded from the index entry. Otherwise, the key or the index entry stores a pointer to only the first record with the search key values. In this case, if the deleted record was the first record with the search key value, that is, the deleted record is the first record that is available with the search key value, then the system updates the index entry to point to the next record. Now, next is the sparse indices. If the index does not contain an index entry with the search key values of the deleted record, nothing needs to be done to the index. That is, nothing will be done with the index value that is available with the indices. Now, insertion and the deletion algorithm for multi-level indices are simple extension of the schema just described. So, whatever the scheme that we describe, that is just the extension in case of the multi-level indices. Then next is the secondary indices, that is what is the meaning of the secondary indices and how and why we are using, or at what place we are using the secondary indices. So secondary indices must be dense with an indent entry for each search key value. That is, every index value contains the search key values and are pointed to every record in the file. A clustering index may be sparse, storing various records or storing the records that with only the sum of the search key values, since it is always possible to find with the intermediate search key that is available with the sequential access to the file. And a secondary index that is available on the candidates key look like a dense clustering index. So it's just look like a dense clustering index that is available with the search key. Now, what is the main exception that is used with this index? That is, main exception is that the records pointed by the successive values in the index are not stored sequentially. In general, however, secondary indices may have a different structure from clustering indices. If the search key of a clustering index is not a candidate key, that is, if you are searching the clustering index that is not a candidate key, it suffices if the index points to the first record with a particular value for the search key. Since the other records can be fetched by a sequential scan of the file, that is, whenever we use the scanning system, whenever I want to fetch any record, that is fetched by the sequential scan of a file. In contrast, if a search key of a secondary index that is available is not a candidate key, that is not a candidate key that is available, it is not enough to point to the just the first record with each search key value. So it is not pointed to the search key value that is available with the search criteria. Now, a sequential scan in the clustering order is efficient because records in the file are stored physically in the same order as the index order. So, sequential scan, or whenever we do the sequential scan, that is very better one because it is efficient because records in the file are stored physically in the same order as the index order. That is, there is no change in the order that is in which they are defined. Next, secondary file or secondary index on the instructor file or the non-candidate key, that is the salary. Now, what is the automatic creation of the indices, or how the automatic creation of the indices will be possible? So if a relation is declared to have a primary key, most database implementations automatically creates an index on the primary key. So if any relation that is maintained on a primary key, so most of the database implementation that is made, that is automatically creates an index on the primary key. Whenever a tuple is inserted into the relation, the index can be used to check out or check that the primary key constraint is not violated. That is, there is no violation of the primary key constraint. That is, there are no duplicate on the primary key value. There is no duplicate value that is available on the primary key. Without the index on the primary key, whenever a tuple is inserted, the entire relation would have to be read to ensure that the primary key constraint is satisfied. So to satisfy the constraint that is available, that is done by the automatic creation of the indices. That is, there will be automatic creation of the indices that is available in the login file. Because secondary key order and the physical key order differ, if you attempt to scan the file sequentially in the secondary key, the recording of each record is likely to require the reading of the new block from the disk. That is, there is a new blockage of the disk that is available in the secondary storage. The procedure that describes earlier for the deletion and the insertion can also be applied to the secondary indices. So whatever the procedure that is described that will be done, that can be applied to the secondary indices. The actions taken are those described for dense indices storing a pointer to every record in a file. And if a file have a multiple indices that is available, whenever a file is modified, every index must be updated. So every index must be updated if the file must be modified with each other. Secondary indices improves the performance of the queries that uses the keys other than the search key of the clustering index. So if we are using the clustering index, the performance will be updated. The performance will be carried out with the clustering index. However, they impose a significant overhead on the modification of the database. That is, there will be a significant overhead that will be available on the modification of the database. The designer of a database decides which secondary indices are desirable on the basis of an estimate of the relative frequency of queries and modification. That is, whatever the relative frequency that is available, that will be modified by the frequency index. Now, Next is the how to use the indices, or what is the meaning of indices on the multiple keys. That is known as a composite search key. That is, we are using more than one attribute for searching any concept, for searching the key, for searching the multi-value key. That is known as the composite search key. So if you are using more than one key or more than one attribute for searching the keys, that is known as composite search key. Next is the B plus tree index file. So what is the main disadvantage of indexing or the index sequence file? That is that performance degrades as the file grows. So as the file grows, the performances degrades automatically, both for the index lookup and both for the sequential scan through the data. So that will be not be available for the index sequential or the index data. Although this degradation can be remedied or can be remedied by the reorganization of the file. That is, this degradation may be possible or can be rectified by the organization or reorganization of the file. Frequent reorganization are undesirable. The B plus tree index structure is most widely used of several index structure that maintains a efficiency despite insertion and deletion of the data. That is, despite the insertion and deletion, there will be index file that will be maintained for the inserting and deleting of the data. A B plus file index that takes the form of a balanced tree in which every path from the root of the tree is the same path. That is a balanced tree, that is the same path is available for the routing part, for the destination part. Now what is the structure of the B plus tree? That is a multi-valued index, multi-level index that has a structure that differs from that of the multi-valued function key that will be available for the function values. And we consider the structure as a leaf nodes that is available for the B plus tree, that is contains the instructor file, that contains a search key, that is a name key, for example. This is a typical node of a B plus tree. That is how to use the B plus tree, that is how to make the B plus tree that is used with the various indices. That is a leaf node for the instructor B plus tree index. And there are non-leaf node that is also available from the multi-leveled indexes that is available, that is used on the leaf nodes. The structure of the leaf node is dealing with the application that is used for the various t point or various n by 2 pointers. This is one of the example. That is a Mozart. This is the Einstein, Gold, Srinivans, then Brand, Califrey. These are the various concepts that will be used in the. Now, how to maintain the queries on the B plus tree? That is how to find the values, how to maintain the queries. So let us consider how we process the queries on the B plus tree. Suppose that we wish to find the records with the search key value of the V. Suppose we want to find the records on the search key value. Now figure 11.11 present the pseudocode. We can see the method how to find the function, that is how to find how to use the find function to carry out the task. Intuitionally, the function starts at the root of the tree. This is the root of the tree, and traverses the tree down until it reaches a leaf node that would contain the specified value. So it will work until it will reach to the specified file, until it will reach to the specified value if it exists in the tree. Specifically, starting with the root as a current node, the function repeats the following steps until a leaf node is reached. So it moves further till the leaf node is achieved. This is the P plus T with the instructor file with n equals to 6. That is the number that is available is the 6. This is also the theoretical concept that is used in this one. Now how to update on the B plus T, that is in the same way that is used for insertion, deletion and the various method that is used for the delete key, that is used for the various concept that is used with the concept that is used with the insertion keys. Now, whenever a record is inserted into the deleted key, that is, it is used with the deleted key, the indices will be maintained that must be updated correspondingly. So it must be updated correspondingly. So it must be used, and hence it must be updated automatically. Hence we only consider the case of the insertion and the deletion. So there is the only concept of the insertion and the deletion that will be used for the modification of the insertion key, that is how to modify the data or how to insert the data. Now, Next is the insertion, that is how to maintain the insertion and how to make the insertion that is available with these concepts.